Welcome everyone to the 2020 APEC Groundbreakers Virtual Tour by APEC OUC. This year our event would be the biggest one ever done, with 174 sessions, including normal sessions, workshops and hands-on labs, from 123 different speakers over 11 days. Also, it would cover sessions in 4 different languages. Please remember to register for as many sessions as you can. All sessions will be available for replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during those 2 weeks by posting questions or comments directly in the playback session page. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Reverse Engineer Machine Learning to Develop Performance Monitoring Rules by Craig Shallahamer. Please feel free to write questions at any time during this session using the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If you experience any issues during the presentation, please feel free to contact me at any time using the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Craig Shallahamer.
Right, well, let me share my screen and we will get ready to go. Oh, you need to not share your screen, I think. I'm unable to, there we go. All right. Fantastic. All right, well, hey, welcome everyone. Those of you live and those of you watching the recording, so good to have you here. My name is Craig Shallahamer and I'm going to be talking about machine learning today, but it's kind of an upside down way of looking at it, and I thought it'd be really interesting, and there's definitely some use cases, so we want to start with that. So if I seem a little loopy is the word, it's midnight here and I slept for a few hours and just woke up, so I'm not quite 100% there yet, but hopefully I will get there. So let's get started. So here's the situation that I based the presentation on. Okay, it's like this. You know, machine learning is a super big deal right now. Everybody's talking about it. I haven't seen anything like this since I started learning about relational technology back in 1989. It looks to be really exciting. It's used all over the place in different areas of business and research. And so a lot of people say, hey, I want to get in on the fun. But we're in IT and it's different. And while some organizations are checking out machine learning, you know, your organization may not be embracing it at all, or maybe just a little bit, or you're not able to get involved. So, but you are responsible to monitor hundreds and maybe thousands of Oracle systems, and big and small. And that's not going away. In fact, that's increasing. That burden is increasing on you. And you know it's not sustainable. I mean, it's just not going to work like you've done it in the past. And so you're wondering, like, am I the only one in my organization that actually sees this just giant wave come toward me that is just unsustainable? So the question you might be asking is, hey, maybe there's a way that I can still use machine learning, even though it's not being embraced by my organization. It's kind of a backdoor way to do it. And so one solution is, yeah, you can do that. You can use machine learning, but to do it, we're going to have to kind of do it in what I'm going to call stealth mode, which means people may not even know that you're actually using the machine learning, but you're going to come up with monitoring and alerting rules using machine learning, but it's going to be more of a manual approach. It's not going to be completely automated, although you could actually automate it as you'll actually see. So let me explain how this is going to work. So see, your monitoring and alerting systems are probably rule-based, and you can create and modify the rules. So maybe we can kind of flip this and say, well, what if we use machine learning to actually create the rules for us? The reason that this is possible is because in machine learning, there's a structure called a decision tree. It's a model. It's an algorithm. There's different types of decision trees, and they are essentially just a bunch of if then else statements that indicate if an alert is actually warranted. So is it possible to generate these if then statements using machine learning? And can you integrate those into your existing systems in like this stealth mode? And yeah, of course you can. That's what I'm going to show you how to do in this presentation. So real quick about myself. Again, my name is Craig, and I'm a longtime Oracle DBA, and I specialize in predictive analytics, machine learning, and also, of course, a lot of Oracle performance tuning. So I do a lot of performance research, and I put that in my blog. Author of a couple books I'm really proud of. I do a lot of conference speaking, teaching, mentoring of Oracle DBAs primarily. And I'm also an Oracle ACE director. And I'm really involved in Oracle user groups. And I've been the DBA track manager for the IOUG conference for many years, which is now part of the Quest conference, not the Quest company, Quest, the conference. It's really confusing. So OraPub is a company, and it's all about empowering primarily Oracle DBAs and developers who want to take Oracle performance skills to the next level. And we focus primarily on like performance firefighting and also machine learning. And so on my website, there's a ton of free resources out there, but I save my like premium resources for my OraPub members and for paid OraPub members. I do a lot of webinars specifically about performance. We actually have over a library of over 110 recorded performance-focused webinars right now in our repository. Super cool. Anyway, there's a lot of stuff out there. If you're interested in that, just go to my website and check it out. Okay. One kind of special thing I want to let you know about is I have a self-paced. It's a 16-module machine learning e-course, and you receive an email with just a little bit of description and some raw Python machine learning code that you can literally copy and paste into Python. In fact, the first session is how to actually set up this environment so you can do it. People love this thing. Hundreds and hundreds of people have gone through this. And the objective is just after a few sessions, you will know whether this is something that you're interested in or you want nothing to do with machine learning. So that's really what it's about, is to give you a really safe way to kind of check out machine learning. So let's do some machine learning. Now, you need to know that under the umbrella of AI, we have machine learning. And there's two main, I'll say, pillars of machine learning. We have supervised learning and unsupervised learning. Now, one of the challenges for DBAs when you start doing machine learning is there's a completely new vocabulary. And one of the really kind of frustrating things is some of the words, I mean, we actually use, but we don't use, machine learning folks use different words for the same things that we talk about. An example is a column and a table. Well, the machine learning folks call this a feature. So it takes you a while to kind of get all this straight. And by the end of this, you should actually know a bunch of these words. So a really good way to understand the differences between supervised learning and unsupervised is when we're doing supervised learning, it's like we have the answer to the problem. We have a lot of historical data. And so here's an example here. Let's say this is AWR snap data. Maybe this came from DBA HIST sysmetric summary. And so we have a snap ID, and then we have some various metrics like user calls per second, average active sessions, transactions per second. And so what actually happened is that related, like over this snap, related to these, to say performance metrics, the performance situation was deemed bad. All right, and so it's labeled bad right here. This is this column, and this is actually called a label in machine learning, sometimes called a target. So this label of either good or bad, there are discrete values. There's two of them, either good or bad. And this is what makes this different from a supervised learning regression problem. This is a machine learning supervised classification problem or model that we're going to need to use because our labels are discrete. We have two of them, good and bad. Now, these labels, where do these come from? Okay, these are not the result of math that you do. This is the trap DBAs fall themselves into. You know, they say, well, let's just do some math to figure out, you know, the mix here of what causes performance to be bad. Well, if you could do that, then we do not need machine learning. All we need is your math. And that's a problem because it's not working. All right. If it was that easy, we could actually do that. So machine learning, what we do is we get this label from a different system, like a support ticket system. And then so what we do is we have this relationship between the performance metrics with the performance situation. And based on the number of tickets, then that can actually, we can determine whether performance was actually good or bad. It's actually more closely related to the user experience. So we are related the metrics with the user experience. Okay, so we always have a label. So what we do, and you'll see us do this, see me do this, we're going to take this data here and we're going to use this to build a model. We're going to train a model. And then once the model is deemed trained, we're going to give it the most recent snap ID data, attributes about the performance situation, sometimes called features of the situation. We're going to give this data to the model, and then the model will predict what the label is going to be. That's the predictive power of a model that is able to do that. Now, how do we know if it's good or not that good? Well, we have some techniques to evaluate the accuracy of the model, and I'm going to share those with you. So this is the type of model that we're actually going to do. What we're going to kind of uncover and pull out of machine learning is the rules as a result of this training right here. So then when you have a situation, or you take the most current snap data, we say, hey, machine learning, what's the performance situation going to be? Like, is the phone going to start ringing with angry users? And that should give us a clue so we can prepare for that and start looking to solve the problem before people actually start contacting us. And that's the goal here. With unsupervised machine learning, it's different. There is no label. We don't use the label typically. What we're doing is that we take all, like one application of this is that we take all this data, and one model we might use is called a cluster model. So like we take all these points and we create like this cluster. And then we say, okay, in all the points in the cluster, which point is related to the most recent snap data? And we'll say, maybe it's this point right here. And then what we do is we look at the cluster, the main cluster, and say, hey, the main cluster is over here, but the most recent snap data, its point is way over here. It's like, it's outside of the cluster. It's highly unusual. It's anomalous. So we've detected an anomalous performance event. And we can use unsupervised machine learning for anomaly detection. That's what I use it for typically. But we're not going to do anomaly detection this time. We're going to actually extract rules from a supervised model so we can actually do the actual predictiveness in terms of good or bad, that kind of thing. And actually, we're not going to just do good and bad. Our prediction is going to be, is performance going to be green, yellow, or screaming red. That's what we're going to use for our labels. So here's the process at a really high level that we're going to go through. What we do is we have attributes, for example, like a picture of some animals, let's say. And these attributes are called features. So actually, if I go back here, like this user calls per second and average active sessions, these are called features. These are features or attributes of the performance situation. And of course, then this is called the labels. We have features and label, very separate, but very important. So the pictures is our feature data, and the label is it's a duck or it's not a duck. Notice we're not trying to determine if it's a rabbit or a hedgehog. We just need to know, is it a duck or not a duck? That's the objective. So what we do is we give the pictures plus the label to the machine learning algorithm, and it then produces a predictive model. Now, this is really important for us to understand. The predictive model, it's not about memorizing the data, because the power of a predictive model is when we give it a picture it's never seen before, but it kind of looks at the picture at the attributes and it says, or the features, and it says, well, I see 2 feet, I see a beak, feathers. That's probably a duck. So I'm going to go with it's a duck. And that's what we want our models to do. See, if the models just memorize the data, we wouldn't need machine learning. All we need is a where clause in a SQL statement. All right, so it's not about memorization. It's about like understanding the features of the whatever we're looking at, like a duck, animal, performance situation, that kind of thing. All right, so that's kind of the process I'm actually going to bring you through. So what we're going to do, the type of algorithm and model that we're going to create for supervised learning, we're going to be using what's called decision trees. Now, there's a number of different algorithms associated with decision trees. And what I think we're just going to use like a traditional decision tree that it's not anything special or exotic, but man, it's amazing how well these things work. So what I'm going to do is to show you how you can actually build out the tree. This is going to be Craig's decision tree algorithm, and it can make it a lot simpler. So what we have here, we actually have 10 rows of data. Okay, we have 10 rows, and each row contains some feature data, average active sessions, and CPU utilization, and then the performance label, which is good or bad in this situation. Now you'll notice though, I said there was 10 rows, but I'm only showing you 5. Because what we're going to do, we're going to use 5 of the rows to build the decision tree, to create the model, and we're going to use the remaining 5 to actually test the accuracy of our model. You hear that bird? We have finches in the office, and that's what you're hearing. I woke the bird up. He's not happy. Anyways, so all right, we have 10 rows of data. We're going to use half of them to actually train the model and half to actually test our model. So let's build the model. Now, the best way for me to actually do this is I actually want to cover up some stuff. So we're actually going to use what's called a notepad later. So let's see. Let's actually, let's do like, I guess we'll do that. Don't be distracted by this. I wonder if I could just...
I can't see your screen. Are you sharing it?
Oh, no, you can't. Okay, let me reshare it here. Okay. Wow, we went through all that and we couldn't share it. Oh, that's really too bad. I went through a bunch of slides. Okay, well, so what I'm going to need to do then, a lot of that was intro. I do want to show you, here's the URL to get the e-course. So I'm going to put that in for chatting. If anybody can see that, you can see that's a little easier. The other thing is that we need to, that's too bad you couldn't see. Thank you for letting me know about that. But I was referring to the supervised and unsupervised. Here is our performance data. You can see the label, or you can see the features, 3 of them. And then we can see the performance label right here, which we got from, let's say, a ticket system. And you're actually going to see how I do that when we actually do this for real. Okay. So the key here, though, is with what we're going to be doing, we're going to build our model on some data. And then we take like the most recent snap and we say, hey, what's the performance situation going to be? And so we're actually going to predict the label there. Okay. All right. So, yeah, thanks for letting me, let me know that. Shoot. All right. So this is our data we're going to use to train the model. We have the feature data and we have the label data right here. And I have another set of 5 rows we're going to use to actually test the model. So let's actually go ahead and build the model here. Okay. So what we're going to do is, this is what I was doing before. Here, this is what we're going to do. Okay. So we look at our training data and we're going to go through every single one of these 5 rows and we're going to build out a tree. So how do we know whether we branch left or right? Whether the answer to the question is yes or no? Well, it's my rules that I created, and every machine learning decision tree will have its own rules, and it actually creates the rules. Okay? And so these are going to be Craig's rules. And so what we're doing here, first, we're going to look at the average active session data. And what we're going to see is average active sessions is it less than 9? Well, how did I come up with 9? Well, that's my algorithm. And so what I did is I looked at all the rows that we're going to use. I look at the average active session feature and I say, what's the high value? 14. What's the low value? 4. Add those together and I divide by 2. So it's like an average. Okay, but it works good for a demonstration right here. And so that's where the 9 came from. So I look at my first row and I say, hey, the first row, its average active session is 4. Is that less than 9? Yes, it is. So I branch to the left and we can see now I put row 1 and I put its label G for good. So it's labeled good performance. Then we go to the second row and with its average active session is 6. And I say, hey, is 6 less than 9? Well, yeah, it is again. So it goes down the Y for yes branch, and that's our training data number 2, and its performance is labeled good. So we go to the third row and we say, hey, its average active session is 10. Is 10 less than 9? No, it's not. So we branch to the right and we have our third row and its label is bad. So performance was bad in this situation. This is actually historical data, right? This is like truth. We're building out this tree based on historical data. And then we look at the third row and it's a 10. Oh, I just did 10. Let's look at the fourth row. That's 14. Say, hey, is 14 less than 9? No, it's not. So it goes to the right and this label is bad. And we have the final fifth row. Its average active sessions was 12. So is that less than 9? No, it's not. So we've gone through all of our data right here, our training data. Now, this is really important. On the left here, you'll notice that both of the rows that went to the left are labeled good performance. So what this means is anytime this model sees average active sessions of less than 9, it's going to say performance will be good. It will be good. So if somebody says, hey, Craig, average active sessions is 8, what's performance going to be? I will look at the decision tree and I will say, it's going to be good because the endpoint is here. And every time performance has been good when we travel down this branch. But if I look over here to the right tree, performance is usually bad, sometimes good. So it's not fully developed, let's say this leaf. So we want to take it down another level. And so my algorithm said, well, first we're going to look at average active sessions. Next, we're going to look at the CPU utilization. That's the feature that we're going to focus on. And so what we do, we take the remaining 3 rows that we haven't like fully qualified yet, and we're going to look at its CPU utilization numbers. And so we look at this first one and we say, hey, row 3, its CPU utilization is 50%. And oh, by the way, we did we have our threshold 55 because we took the high value 6, the low value of 50 because we're only looking at the last 3 rows right now. And we divide by 2, so our threshold is 55. So if I look at the third row here, I say, hey, is 50 less than 55? Yes, it is. So I branch down to the left and I put the third row with bad performance. And we do this for all three of the remaining rows. And so like what happened above, one of the branches ended in it's always bad. There's not a mix of good or bad. And so like we're done on that branch. But on the left branch, it wasn't like that. All right, we still have a bad and a good. And so we go through this again and we flip back from CPU. Now the question that we're going to ask is going to be related to average active sessions. And we just keep doing this until all of our training data has been like placed into the tree properly. We're kind of building this tree. And this happens incredibly fast when we not with 2 features, but hundreds or even thousands of features. This can just boom, happens in a split second with thousands and thousands of rows of data. It's amazing how fast that can actually take place. Now, if you think about this, what we've done here is we created a series of if then else statements. And so in my next slide here, I just took the tree information and I converted that or transformed that into some if then else statements. And you can see, like, let's just take our first piece of data right here. Our first row says what we're looking at is 4 less than 9. Yeah, okay, performance is good. That the models say it's good. And that's correct because it is built into the model. So you can just see how we can just work our way through the decision tree. Now, so we save the decision tree information, the if then else statements. Okay. And now we're going to test the quality or the accuracy of our model. So we're going to subject it to data it's never seen before. This is going to be our testing data right here. So it's the same, it's just another 5 rows. Remember, we started with 10. I had 10 rows of my data set. We used 5 for training. We're going to use 5 for testing right here. And so let's just, there's one additional column here, right? We have the predicted performance because we know what the feature data is and we know what the actual performance was. Now we want to predict, what does the model say performance is, what should it be? And you'll see sometimes it gets it correct and sometimes it doesn't. And so I'll give you an example of when it's correct and when it's not correct. So our first testing data right here. So its average active session is 20, which is greater than 9. So now we go down to the else statements right here. And then I say, is the CPU utilization, which is 70 in this row, is that less than 55? No, it's not. Therefore, the else statement says, I predict performance will be bad. And guess what? The prediction was bad and the actual performance was bad. So the model predicted correctly. But if let's take the next row 2 here, okay, its average active session is 10. So is 10 less than 9? No, it's not. So we go down to the else. Then we say, is the utilization less than 55? Utilization is 40, so yes, okay. And now we ask, is the average active session less than 11? Yes, it is. Therefore, I predict performance will be bad. But we know performance was actually, in fact, good. So the model incorrectly predicted the performance. And so if you look at this, out of the 5 testing rows that we have, we got 3 correct. The model made 3 correct predictions and 2 that it got incorrect. And so we can use some super simple math to determine an accuracy score. Just take the number of correct samples, divide by the number of samples, and it comes out to 60%, which is pretty crappy for a model, but it's really good for a demo, okay? So you can see how it's actually created. So this is just one way to check the quality or the predictive power of the model. And It works pretty good, but it's very, very limited. But for what we're going to be doing today, it's good enough. And I just wanted to introduce that to you anyways. Okay. Now we can make this so much better. And that's what I teach in my classes. I mean, honestly, there's better ways to determine accuracy. Um, do we need, like we only use 2 features, but if we have hundreds of these things, like, do we really need all of them? And if we don't, which ones are the best ones? Okay. How about we use some ASH data instead of sysmetric data, or use both? And we have to deal with this situation. It's called rare event. And in our data, Oracle performance data, we have to deal with this reality that bad performance should be a rare occurrence. It's a rare event in machine learning. Well, there's some challenges with that, because if the model doesn't see very many examples of poor performance, it usually doesn't do a very good job of recognizing poor performance. See, performance is usually good. It has like a lot of experience. It's really good at recognizing good performance, but we need it to recognize poor performance. That's really why we're doing this. And so there's a challenge, and decision trees have a problem getting good at predicting rare events. But there's some things that we can do to actually address that. We can try other models, and we can actually tune the models. Every model has parameters, and there's actually a lot of other things that we can do, but we're not going to do those things. We're just going to go for the core, the core things here. All right, so let's go into stealth mode, and let's actually do some machine learning and see how we can get these rules out. And you're actually going to get some insights into decision trees as well. Now, I'm going to do this. I mean, I'm going to actually, the demo I'm going to use, you're going to need to set up a machine learning kind of sandbox if you want to do this yourself. It's really easy to do. And if you're going to do any machine learning, you got to create your sandbox environment, just like when you learn Oracle stuff. So what you're going to need to do, just go to my blog, blog.orapub.com. And here's the full URL. But if you just search for the word sandbox, then it'll bring you right to the page. And you just download, install the software. It downloads on Windows, on Mac, OS X, on Linux. Just use Windows or a Mac, and you'll be fine. Okay. And so once that's set up, you're going to be able then to use this actual, what's called a notebook right here. Okay. And when tomorrow, when I wake up, okay, after this, I will actually put my slides, and the recording will be online, I think, here, but we didn't get those first slides shown. But anyways, you'll be able to download the slide deck, and you'll be able to get the notepad. So you're going to be able to do everything that I'm going to do in machine learning. Yeah, excellent. The recording will be available for you guys. So I will make everything else for you available when I post it on my website. I'll show you how to get that at the end. Okay, so once stuff's on my website, for you to find it, you got to go to orapub.com. You're going to need to log in. Okay, and so to log in, you need a login. And so it's a membership website, but you can be a free member. And then you just log in, navigate to tools and presentation, and you'll see all the other stuff you can download as well. So let's go ahead and actually do the demo. Now, if for some reason you don't get your machine learning environment set up, or my demo just completely fails, what I do is I actually have screenshots of some of the key parts of the demo. So these are my demo failure slides, I call that, just in case it just crashes and burns. But we're not going to need that, because it looks like the demo's working perfectly. So what you do is we're going to use what's called a Jupyter notebook. Jupyter is the industry standard right now for notebooks used for machine learning. And Python is actually the industry standard for machine learning code. Okay. Oracle is doing a fantastic job of taking the machine learning algorithms, putting it into SQL and PL SQL. And we can actually pull the Oracle data into Python, but a lot of times it make more sense to actually use Oracle's machine learning SQL and PL SQL. The advantage of that is that a lot of the data is already in an Oracle database. So why, in a sense, copy the data someplace else and then do all the number crunching? So let's move the algorithms and do the number crunching on the production database. Ooh. Well, if you're a DBA, that you're probably like, what? Wait, we're going to move number crunching intensive processes onto the database server. Yeah, that's something that you have to deal with if you're going to take that approach. Okay, so but we're going to use Python right here. And by the way, Python is awesome. I'm not a Python expert, and when I first started doing machine learning, I used to do everything in Excel. Then I learned R, the free statistics package. But Oracle, while it embraces R like it embraces Solaris. Python is like the Linux of Oracle. You know, Oracle doesn't care whether we go R or Python. It doesn't care whether, you know, the industry goes Solaris or Linux. It's good either way. So they're playing that same game. And right now it's going toward Python. All right. So that's why I said, okay, I need to learn Python. And I'm really glad I did. So we have a notebook. Notebooks are fantastic for developing and for teaching, because every notebook vendor, the notebooks are divided up into cells. And like, here's a cell right here. Here's another cell right here. This cell is called a markdown cell. And if I double click it, you can actually see the underlining markdown, you know, code, I guess, right there. Now, every cell can be evaluated. You see, with a notepad, we can run one cell at a time. So you don't have to run like the entire program. You just run one cell. So it's a really nice way to develop and to teach, because you don't have to keep rerunning the thing all over and put all sorts of debug statements all over the place to highlight certain things. So to evaluate the cell or to run the cell, you can hit the run button right here, or you can hit Shift Enter. In most notebooks, surprisingly, Shift Enter is the evaluation of the cell. So if I click run, click, you can see we have that. So let's actually evaluate this cell. And that's going to load some Python library. So we're going to click run, and boom, you can actually see that. What do I see on my screen here? What the heck is that? That's kind of bizarre. Okay, something's going across. I'm having the weirdest thing here. I wonder if that'll go away. What the heck is that? I don't know. That's really, I wonder if that'll go away. Well, we'll hope that that's going to go away from I don't know what happened. So, you know, I wonder if that's on my, that looks like an email. I wonder if that's on my camera. Oh, I'm going to touch my phone, which is my camera right now. We're going to see what happens. Oh my gosh. I've never had that happen before. Dang. Of course, it has to happen at 12:40 a.m. my time. All right. So when it comes to the cells right here, I'm not going to go through all the detail on this. I just want to highlight some things. Okay. I tried to comment all over the place. And if you're really curious, you can figure this all out on Google, or, you know, I teach all this in my training classes as well. So we're going to, the first thing, and this is where you're actually going to make the changes in this cell right here. I have two different data sets that we're going to use. We're going to have a really small data set, which has like a dozen rows in it, super small. So we can actually see a really small decision tree that's been built. And so we're not going to get complicated with the realities of real data, real Oracle data. And then I have some real life sysmetric data that we're going to have not 2 or 3 features. It actually has 161 features, and we're going to use that to build out a decision tree. However, though, when you have a lot of features, the decision tree gets really, really big. And one of the objectives of this presentation is to kind of hone that down to just a few if-then statements or a few rules, so you can put these into your monitoring and alerting systems. Now, you'll see that I've kind of taken a couple different tactics on this. One is to create a really small decision tree. However, when we kind of reduce the decision tree, make it small, the predictive power of the decision tree is not very good. So we want a bigger decision tree. It can hold more information. But to do that, it's like you're going to need to automate the code that you would then put into your monitoring system. So I've given you the ability to do that. You're going to need to modify this to whatever like language you do your monitoring in, but you'll see that the capability is there. It's super cool. You're going to love this. So we're going to start with a small data set. And the depth of our decision tree, I'm going to set as 4. And we're going to use that for all of our demo. Now, one of the other way to keep the decision tree small and to keep it like really like kind of tight and powerful, the most powerful we can make it, is to use only the most important features. Remember, I mean, our small data set's only going to have 3 features, but the big one's it's just metrics. So we're going to have like a lot of metrics. And so what we're going to do is there's algorithms. We're going to use a machine learning algorithm to select the best 3 or 4 metrics for us. And we're going to use that to build the tree. Now, if we have enough tree, I'll have it build it with like 100 metrics, and you can see the tree. It's going to be huge. And it's like, wow, that's really cool, and all that kind of thing. Okay, and this is just some parameters for scoring. Like, you don't need to know about that. Now, when you do this, this is when it creates the decision tree, it's actually going to create a picture. Okay, and we're going to be able to create a picture of this thing. So where's it going to be on your computer? Well, it's going to be in this directory right here. So when you do this, you're going to need to modify this to be wherever you want that picture to be created. Okay, so you need to change this for your environment. Okay, so let's go ahead and evaluate this, and it looks good. Now we need to score or evaluate our models. Okay, and so I'm not going to get into how this is done, but I will tell you this is how I actually do all my Python work now. I usually have one little comment up here, and then this is how you define a Python function. So this is the function definition. But in the same cell, I actually have the testing code so I can test the function. This is another reason why I like cells for teaching and for learning and exploring, because I not only I can functionize everything, but then I can actually test it in the same cell. So it's super good. Okay, so this is just the testing. So when I evaluate this, it's going to create the function, and it's actually going to do the test. So it's actually doing the scoring right now of the model. You see it, boom, here's the result. So what we did, I used a publicly available data set to actually do the testing. It's called the Iris data set. And so in this data set, we have our feature data, and we have our label or target data. Now, this is one thing you're going to have to get used to in machine learning, is that the feature data many times is like the array is a capital X is going to be the feature data, and the lowercase y will be our target or the label data. Yeah, it's a hassle to get used to. So if you want to, and I used to do this all the time, but I don't anymore, is I'd actually change the variables to something like X, feature, and then Y label. And I used to do, and that made it easy for me because I just wasn't used to it. But after a while, you get used to it. And in any documentation, anything you read or you do, it will always use X and Y. So you just got to get used to it. So I put a Q there because I'm just doing some QA, like some testing. And so I just prefixed it with that. So anyway, so this is my scoring function right here. So once I create it, then I'm actually going to call the function right here. So I'm going to give it my model, my feature data, my label data, and then here are some of those parameters that have to do with the scoring right here. And so when it looked at our data and it did the scoring, or essentially what it did, it actually built the decision tree. We're just testing it though, off this test data. It did the scoring, and the average score was 0.94. So if you remember in the PowerPoint presentation, the score there was only like 60%. So we're like way, way better here with the data that we're looking at right now and the tree that we created. Okay, so we're going to score the model. Now, the data sets. Okay, the data sets I have for you are at this URL. And I actually changed the code literally last night. So this will be really, really simple. If you actually have the CSV file on that directory that you set up above in the notepad, then it'll try and find it. If it's not there, it will then pull from this URL. I mean, it's that simple. So it's super cool. So we're going to load the feature data and we're going to kind of clean it up. So what's the cleanup? Well, I'm going to get rid of some spaces. I'm going to lowercase all the metric names. And I'm actually going to create a couple additional features. One's going to be a feature with a lowercase snap ID, and the feature, like the name, is going to be a lowercase average instead of uppercase. Okay, so I'll just run this. Again, this is this is not a function right now. We're actually doing this. So I actually loaded the real data that we're going to use, which is the small data set right here. Okay, so this is not real exciting because this is test data down here, but these are all the columns or the features that we have right now. Okay, now what we're going to, okay, this is really important. It's really upside down for us DBAs, right? We've taught and we've told people, and we've done this, we normalize like everything. And there's really good reasons for that in our systems. But for me, machine learning, you have to completely denormalize. It's like completely reversed. So what that means is like for every snap ID, all of the features, right, will be essentially a column. Now, sysmetric data is normalized, right? It doesn't have a column for every feature. It has a column called metric name, and a column called the average, which is the value. So what we're going to do is we're going to take that normalized data and we're going to pivot it. We're going to denormalize that, and we use a pivot table function in Python to actually do that. Okay, and so you'll see this. It's going to be kind of, since this is the small data set right here, so it's not super really exciting, but I have. Well, you'll be able to see this when we actually look at the data more fully here. But we had 27 rows with 3 features, but once we denormalized it, we actually only have 9 rows because there's like 9 snapshots, and now we have 4 features. Not a whole lot more. It's very dramatic when we look at sysmetric data. So when we run this with the big data, you're going to be like, oh wow, that's cool. All right. So that's the feature data. We're all ready for the feature data. Now let's load our label data right there. And again, we're going to use the small. We're going to use the small for this one right here. So let's go ahead and load that. And I'm showing some statistics. So now our label data, notice the label data is a bunch of numbers. It's not green, yellow, or red, or bad, or good. We're going to determine the label based upon the number of tickets, like support tickets that were entered per snap. So this is coming from like it's a different system, different application, right? So we're gonna have to get that data, and that's gonna be the trickiest thing about doing this whole thing in real life is to actually figure out how am I gonna get label data and what is good label data. That's a long discussion. It's not an easy thing to figure out. Well, what we're gonna do for simplicity's sake, what we're gonna do is we're actually gonna set thresholds. And so what we're going to do is, now that I've actually I did some stats on the tickets per snap, all my ticket data right here, I'm going to create a feature. Well, let's call it a label, okay, called indicator level, which is going to be green, yellow, or red. So I'm going to set all of the indicator levels to yellow. That's what this line is going to do. It's going to create the label called indicator level, and we're going to set all of the rows to yellow. Now we're actually going to look at the tickets per snap. We're going to say, listen, if the tickets per snap is greater than 154, then we're going to set the indicator, we're going to reset it to red. And if tickets per snap is less than 49, we're going to set the indicator level to green. And so this will actually, so we are determining based on the tickets per snap, whether the label will be green, yellow, or red. Now, what I just did took what, like 2 minutes to figure out, but in reality, you're going to have meetings and you can adjust these to determine what makes sense based upon your data. Okay, so that can be a long discussion, but we're not going to have a long discussion. So what I evaluated this, and there are four rows of our data that where the label is yellow, 3 rows that are green, and 2 rows that are red. Okay, so what we're going to do now is we're actually going to like finalize our label data right here. Okay, so now we actually have all of our feature data. We have all of our label data. Okay, now we wanted to determine the most important features. Now, normally I would not put this in a short presentation like this, but this is important because we're trying to create a condensed version, or a condensed decision tree. And one way to do that is actually to limit the number of features that we will use to build the decision tree. So which features do we want to use? Well, we want to use the best ones, the ones that give the most predictive power. Well, there's actually a machine learning, I'll say, functions that actually determine the most important features, and that's what this does right here. And so remember, we set the number of features, I think, to 3, and it did it, and now it's actually scoring the model. Okay, so what it's done here. Okay, so this is kind of cool. All right, so these are the features right here. Remember, there's only 3 features anyways, but look at the numbers right here. You can see clearly that CPU seconds was the most important feature. The average active session, it's like saying, man, this thing is totally worthless. But I told it I need 3, so it used all 3. All right, and so those are our features. So even if we had a bunch of features, I said I only want the top 3, and so that is the list of the features that we're going to use. So what I'm going to do, now this is a little tricky here. Okay, we're going to take all of our feature data here, and we're going to say, but I only want my top features. And this top features, this list, I created up above, and this is what it contains. So even if I had like hundreds or thousands of features in my feature data, the result of this statement would be only 3 features. It would be these features. So I'm basically recreating my feature data set with only 3 features. Now, I only started with 3, so this is not real exciting, but when we look at the Sysmetric data, it'll be pretty exciting because we're going to go from 161 down to 3 or 4. Okay. All right. So I'm going to reset the features, actually rescore, but we don't need to get into that. Okay. Now, just for fun here, for our reference, I'm just going to show the data. So I combine the feature and the label data so you can actually see the data that we're actually talking about right here. Okay. So there's our features. CPU seconds, outreach, average active sessions. Snap ID is not really a feature. It's not an attribute of our data, but we don't actually do predictions with the Snap ID, but it's good for identification purposes. It's a key, right? So these are our features. And then we have our label, the indicator level, which is red, yellow, or green. Okay. Now, the shape, one of the Python functions will give us the shape of our data right here. And like our full data set right here, I said, hey, what's the shape of that? And here's the result, 9,5. This is rows and columns. So I have 9 rows, which I do, and I have 5 columns, right? 1, 2, 3, 4, 5. Okay, so there we go. I do that a lot to make sure the data is what I think it is. Now, okay, the magic's going to start happening right here. Okay. So what I'm going to do is this right here, we're going to initialize what we already have in wait, where's my model right here? I'm going to where did I initialize my model? I must have did it up above here. And I did that and I didn't tell you about it. Okay. So what I'm going to do this, okay, there's 3 steps in Python. First, you load the library. Okay, then we will initialize the model, and the model is a decision tree classifier. So think of an initialized model like a cursor in the shared pool. We've allocated the memory, everything's kind of hooked together. It's all good, but we haven't put the SQL statement like in the cursor yet. So it's kind of like that. So we've initialized the model. Here, we're actually going to take our initialized model and we're going to fit the model with our feature data and the labels. Oh, here I did use X features to kind of make that a little easier. And the result of that is our fitted model. This is like a cursor that has been completely created and we can execute it. Okay. Now at this point, when I run this code, the decision tree will be built out. And it's going to happen super fast, even with a bunch of data. And what we're going to do, we're going to export some text. This is going to be the rules of the decision tree. So check this out. I'm going to evaluate the cell. Boom, there we go. So I just wanted to show that we have like 3 greens, 2 reds, 4 yellows here. Okay. But this is our data right here that's been built out in a decision tree. So let's take a look at this right here. This is just a little too small, a little too big. Let's look at the first row right here. Okay, so we're going to say, is IO reads less than 50? Yes, it's 10. Okay, so if that's true, then we're going to go down this branch right here. Now it's going to say, is average active sessions less than 55? No, it's actually 100. So it's greater than 55. Therefore, performance is red. It's bad. There you go. And so these are just the rules here. Now, that's all kind of nice and everything, but that's not computer code right there, and it's not very graphical. So there's another thing we can do is we can actually create a picture of this. Okay, and we're the picture has been created. Now, for some reason, it's not created in my notebook right now. I don't know why. It started doing this last couple of days, but it does create the picture, and it's in our working. It's in the directory, and my directory was called DS working, and that's the picture right there. It's this big old PDF, and if we take a look at that, we'll open that up. That's our decision tree right there. Is that cool? All right. Just wait till it gets really big. So you can see these are our statements. This IO reads less than 50. All right. So let's actually go back up here. Let's see let's go right up here. Take a look at that. And you can actually see this built out. So there's our top. This IO reads less than equal to 50. Boom, right here. Okay, and then if it's true, then we say, hey, our average active session is less than 55. That's right here. And if that's true, then we go down this path, and guess what? The answer is going to be green. Okay, it's going to be green. All right, now there's a couple other things I want to show you about this. Okay, there's other data here, right? So we start with 9 samples right here, and this right here gives us the values, the number of values for the green, yellow, and red. Now, this is one reason I showed this right here is because these are the first element here. That's the number of greens, the number of reds, and the number of yellows. Now, you can kind of figure that out because if you look at the bottom here where there's only one color here, and it says, well, it's green. So we know greens are the left, we know reds are the middle, and we know the yellows are the right. But sometimes it's not so simple, okay? All right, so what we want at the very bottom, we want there to only be green, yellow, or red. But sometimes when we try to compress a lot of information into the decision trees, the decision tree at the bottom, it's not pure. But we still need to make a decision whether we're going to say green, yellow, or red. And so you'll see when we get a bigger decision tree how that actually takes place. Like it decides, okay, but there's more greens and we're going to go with green, that kind of thing. The last thing, you'll notice this little genie right here, this stat right here. When that's 0, that means it's like always green or always red or always yellow. When you start to get a mixture, it's not pure, this value starts to increase. And so an example here, you see right here, at this branch right here, we have what, 3 greens and we have 1 red. Now, the overall decision at this point is green, but look at the Gini value. It's not 0 right there. Okay, so that's what that's all about. So that's, I just wanted to show you some of the key pieces there. Okay, now you think, oh, that's great, Craig, but I still don't have the computer code. Okay, so we're going to scroll down here. This is a function I ran. It's going to be we're going to go from tree to code. Now, you will want to modify this, but let's go ahead and run this. And when I run this, then you're going to get the aha moment. You're going to, there we go. Now, if this is pretty close to some kind of code, right? So whether it's PL/SQL or whatever you're going to write this in, you can actually just modify this function to get the codes you need. And you could actually take the rules from the decision tree and put that in a monitoring system. Super cool. All right, now this is real nice and neat and simple and all that, but that's why I wanted to show you this small example. So let's go back up to the top. Let's use some big data and let's look at, well, it's not big data, but let's use actual real production data here. Okay, so we're going to use the bigger data set here. I call that the real data. That's a sysmetric data. Let's keep the depth at 4 so things don't get crazy. And we'll use 4 features. So what it's going to do, it's going to pick the best 4 out of the 161. So I'm going to evaluate this cell. We're just going to kind of scroll down. That function's already been created. There, okay, we did that. Let's load our data and kind of clean it up. This will look a little more interesting right here. So you can see now these are all our sysmetric metrics right here. And you see I lowercase them and got rid of the spaces. All right, so that's what that function up here actually, or what this code did right here, kind of cleaned it up for us, okay? Looks a little more interesting because we have some real data. So these are all those are all the columns in sysmetric right there, sysmetric summary. Now we're going to need to denormalize this, but all we really need, we just need the snap ID, the metric name, and then the value of the metric, and we're going to use the average. So these are going to be the 3 columns. So we're essentially going to have a 3-column table, snap ID, metric name, and the actual value for each of the snap IDs, right? All these different metrics. So we're going to take that, we're going to flip that thing, we're going to pivot it. So I'm going to evaluate this, and this looks a little more interesting now, okay? See, we started with over 200,000 rows, but there's only 3 columns because it's normalized. When we denormalized, instead of 200,000 rows, we have only 1,259. Each row is a snap ID, and all the metrics now have been transformed, have been pivoted, have been denormalized into a column. So now instead of 3 columns, we have 162 columns right here. Okay, we got a bunch, and these are all the features. So I have 100, or I got the around 1,200 rows, and I have 161 features right now. Okay, so we're going to load the ticket data, all right, and we're going to set our thresholds. And so now, because we have a lot more data, we have 772 greens, right, 447 performance situations that were yellow, and we had only 40 that were red, right, because we don't want a whole lot of reds, right? All right, so let's just finish creating the label data. Now we're going to do, we're going to determine the 4 most important features from the sysmetric data. And this is kind of cool. So it's doing the math right now. Done. Did it already. Okay. So there are the top 4. Look at this. Is so cool. This is real data. Okay. I can't make up data this good. Guess what? Clearly the most important feature is database time per second. Are you surprised? DBAs, you shouldn't be. Okay. The other ones are always kind of, that can change around, but typically it's database time per second or average active sessions. Those are also, usually that's up there as well. And I just said, just pick the top 4, but we could do more. So that's the list of our most important features. And we're gonna build out our decision tree based upon that. Okay. Yeah. So now this is all of our data, but that's only really good when we're actually looking at the small data set. So let's actually build out the tree and take a look at it. So this is the old one. I'm going to evaluate this cell. And now we have our symmetric data. Ooh. Now that's the entire decision tree because we only had 4 features. And I said we only want up to 4 levels. Right. But when we do that, it's simple, but the accuracy is not going to be as high. Okay. So let's actually now create the picture. So we just created the picture, and that will be right here. You can see if I look at it now, that's our picture. And we can actually zoom in on that, and you can see a little bit more what's happening here. You can see everything. Okay, so here's a situation where, right at the bottom, it's mostly yellow, but we have a green right there. Here's a situation where it's mostly green. We don't have any reds, but we do end up with some yellows right here. So you see, because we put limitations on the decision tree, we didn't get down to where it's all the samples at the bottom are either going to be green, yellow, or red. There's a mixture. And so the decision tree is going to say, well, it's going to say, yeah, it's going to be green, but you know, it's probably green, but it could be yellow also. And that's because we compress this. And so we lose some predictive power when that actually happens. But it's fast, small, and there's not as many rules. So it's kind of nice. So let's generate the computer code for this. And boom, there it is right there. And now you can see we have the different situations here. It's not so pure. So you would have to make a decision, you know, what you're going to do about that, which would be green. Okay. But there it is. So if you could modify this, so it actually comes out with let's PL SQL, which you could easily do, but I just didn't take the time to actually do that. If you made this PL SQL and your learning system actually used PL SQL, you could then take this code and then just like, boom, you could paste it right in there. Now, if it was as simple as pasting, copy and pasting, what you would then want to do, you would say, hey, I don't want to limit the depth to 4. Like, I don't need to perceive or understand this. I trust the machine learning. So I'm going to say, hey, you can go up to a depth of 40. And how many features? I don't know. Let's allow 40 features. And so let's run this like that. I'm just going to go through the whole thing. So indicator levels, all that kind of, okay, now we're going to have, it's going to decide the top 40 features. So it's doing the math on that. Boom, there we go. Ooh, super cool. Database time per second. Where's average active sessions? Man, it's not up there. That's unusual. I thought it might be up there. Anyways, there they go. But you can see there's a drop off. Now, usually when I teach this, I always have an associated plot, and you can actually see like the first couple of features are really important, and then it just goes way down right here. And you can see it drops dramatically off these first few. So actually only having a few features for this example is actually would be fine. Okay. All right. In fact, when we actually did our evaluation, our models like 0.85, about 86%. That's kind of what it was before with just a handful of features. So we're not actually getting a whole lot more predictive power out of this. All right, so let's continue on down here. Okay, so these are, now we have the rules. Man, we got a lot of rules. Look at that. Woo, a lot of rules right here. But you'll notice that everything is either green, yellow, or red. It's not yellow or maybe green, because we let it resolve all the way down. Yeah, there's a lot of rules right here. Okay, let's create the picture here. Okay, create the picture. Let's take a look at that, and there it is. Now this is quite a bit bigger. Now this is super cool. There's our decision tree. Nice, huh? Look at that. And it's not even nice. Even it just went all the way down. And if we zoom in to some of these, you can see it resolved all the way down. Yellow, always green, always yellow, always green, always green. And it did that. But that's pretty cool. So when you just let this thing go, what it would actually do, like for real, we just get a super nice big old decision tree. Okay. Now, of course, if we want to get the code, and we're going to finish with this, look how fast it generates all the code right here. If you just do this in PL SQL, boom, you got your alerting. So how can you use this? Well, I don't know if you'd actually do this, but there's a couple reasons I wanted to show you this. One, so you can learn about decision trees, but you could also make this really simple. And maybe you could look at how the decision tree is created, the rules, and maybe you could use those to enhance your existing rules. You know, it would be great if you could take the code or take this and put the whole thing in your system. But I suspect that those of you watching this are not actually going to do this. But what I'm hoping you'll actually do something like this, and then you can actually look at your existing rules and say, you know what? Machine learning came up with another really good rule or rule set right here. Maybe we could enhance our existing rules. Plus, it's a great way to learn about machine learning. All right. So I'll make sure you can download the notepad so you can play with that, because you could do all sorts of stuff with that. All right. So let's finish up here. Yeah, so I have screenshots of all of these in here. Turned out pretty good. So if you want to go deeper, okay, we got OrPub memberships. You get discounts on my classes and all the other really cool stuff. I do live virtual training. I'm usually a little more enthusiastic than I am right now, since I should be sleeping. And I have a class, machine learning specifically for Oracle professionals, not data scientists, but for Oracle professionals. And it deals with the things that we have to deal with as DBAs and how we're actually use machine learning and all that. Don't forget about that e-course right there. If you're kind of curious about machine learning, that's a really safe way to do that. And it's specifically for Oracle professionals too. Okay, so again, there's my LVC, and that's it. So here's how you can use machine learning in kind of an interesting, tricky way to possibly enhance some of your rules and definitely learn some more about machine learning. So thanks for listening. I hope this is valuable to you guys. That's it. Do I need to unshare?
Doesn't matter.
Okay.
Are there any questions?
Oh yeah, we do have a few folks live. Fantastic. Sorry, I wasn't sharing my screen at the beginning. I missed some of those slides. Those are my best looking slides too. So I got awesome pictures and everything, but it's all right. All right. Hey, if you guys do have any questions, you can email me too, and I'll check the website also. I didn't even know this, that I can interact with people on the conference website. That's really cool. So I'll be checking that out.
Thank you everyone for participation today, and please do not forget to register for another great session in the conference and to interact with the speakers in their playback session page. Please enjoy the rest of the conference.
Bye guys. Thanks for watching.
Thanks, Craig.
You're welcome. It's my pleasure.